So your guys' screen isn't flashing, is it? Are you guys seeing it clear? It doesn't look like it on my monitor. No, I don't make any money off of it. Nobody is jumping in to watch my YouTube videos. So today what we're talking about is solving quadratic functions, right? We're still in functions, but now we're talking about quadratic functions. By graphing. The worst part of my YouTube videos is that I'm in them, so I will never, ever watch them because I can't stand it. Just watching me right now do this makes my skin crawl. So quadratic functions, you guys have seen them. They're the kind of functions, they always graph in the form of a parabola. Sometimes it'll be like that. Sometimes it'll be like that. Sometimes it'll be like that. I drew these specifically for one reason. But they always make that U shape. They're always what we call symmetric on both sides. Wherever this vertex is, that turning point for it, everything is symmetric on either side of it from there. So our Y values, like here and here, are going to be the same, right? Our Y values here and here are going to be the same because it's divided down the middle. Same with this, right? If I divide it in half right here, my Y values here are going to be the same as my Y values here. My Y value here and here are going to be the same when this is divided down the middle. That gives us a lot of information because once we find that turning point, we can always predict the rest of the points. I drew these in this way specifically because I want to talk to you a little bit about solutions of quadratic functions. The solutions of quadratic functions, little note, solutions of quadratic functions have a lot of different names. Quadratic functions are simply where the graph of the function, I should put the graph of the function crosses, man, I cannot spell today. I cannot spell any day. My hand is not working well today on this tablet. Crosses the x axis. Here's $1 million question. Do you guys remember what we call it when something crosses the x axis? No? Good guess, but no. That's what we should call it, but no. It's actually another word for kind of crossing when you think about it. We talked about it. We did a little section in the last unit on x and y intercepts. That was closer, Valerie, intersection. But we call them intercepts, right? So if you remember where it crossed the y-axis, right? We call them the y-intercepts. And when it crossed the x-axis, we called them the x-intercepts. And so that's really what our solutions are. So if I have a parabola right here, the solutions are going to be these points right here where it crosses that x-axis, right? And they have all sorts of different names. We call them solutions. We call them zeros. We call them roots. And we call them intercepts, right? But really, what they are quadratic solutions. They're saying, what is it when y equals 0? What is x when y equals 0, right? And notice there are multiple types right here. If you look at this one that I have right here, there are no solutions, right? It's never crossing that axis, right? If we're going up here, if we're looking at this parabola right here, never ever crosses that x-axis, right? We'll get into that later because that brings us into the imaginary numbers. But all we need to know about that for now is that if it never crosses this x-axis, there's no solution. Here I have two, right? It crosses right here and right here. Two solutions. There will be the occasion when we have one solution. And that occasion will happen whenever the vertex, that turning point, is on the x-axis. So those are your different types of solutions you can have. You can have no solution, you can have two solutions, you can have one solution, right? So let's get to the meat of this, right? We're going to do a couple of graphs. Ooh, this is so nice because now that I'm online, I can just bring a graph in. I had to draw them for my last class, which, poor them. Because Shaylin's in here. She could see how bad my graph is, except for we drew a face in it, so it's kind of cute. But so the way we're going to find these graphs, say I have a function, right? Let's do it. We've got f of x equals, I can't use that because I made that a homework problem and I can't just give you the homework problem, right? There's only two homework problems. I can't do one for you. I don't hear any sirens outside at the school right now. It's probably my nose wheezing. Just kidding. So what if I have f of x equals x squared minus 4x minus 5? We're going to go old school on this, right? We're going to create a table. Well, Jeremiah did say he knew what that prison food was like. And we're going to put in different values for x. I'm going to start with -2. I always like to throw in a negative, -1, 0, 1, 2. And I'm probably going to keep adding more until I can see that my y's start to come back up again, right? Or go back down again where they repeat. How do I know? So if I put in -2 for x, I've got -2 squared minus 4 times -2 minus 5. And I'm going to figure out what my y value is, right? -2 squared, that's -2 times -2. That is just 4. -4 times 2 would be +8 minus 5. 4 plus 8 is 12 minus 5 is 7. So we know we have a 7 right here. Our next one, we would put in -1. -1 squared minus 4 times -1 minus 5. Well, we would get -1 times -1, which is just 1. -4 times -1 is +4. Minus 5. Right? Well, I've got 1 plus 4. That's 5 minus 5. So we know we have one of our solutions because we got a 0 out of it. Right? Now we got to keep going until we start to repeat and see if we get another 0. Now, unless this is our vertex, we will get a repeat at some point. Right? So my next one that I'm going to put in is 0. So that gives me 0 squared minus 4 times 0 minus 5. Well, these are just 0. And so I know I'm left with negative 5. 1 squared minus 4 times 1 minus 5 gives me 1 minus 4 minus 5, right, which gives me negative 8. Right? And we keep going on this, right? Well, 2. If I put in 2, I get 2 squared minus 4 times 2 minus 5. I get 4 minus 8 minus 5. 4 minus 8 is negative 4. Minus 5 is negative 9. We don't have any repeats here yet, so we have to keep going. 3. Well, what happens when I put in 3? I get 3 squared minus 4 times 3 minus 5, and we keep going. 9 minus 12 minus 5. 9 minus 12 is negative 3 minus 5. Oh, look, we got a negative 8. Once I see that I've got a repeat, I can just look. These are all going to go back up the same way. So I've got 9, negative 9, and then negative 8. My next point should be negative 5, right? I will prove it to you, right? If I put in 4 squared minus 4 times 4 minus 5, right? I get 16 minus 16 minus 5. Well, this just cancels, and I'm left with minus 5. What do you think my next point will be? Yeah. And then the point after that, if I wanted to put it in, would be 7. But this is as far as we really need to go, because we were looking for these where our y's would equal 0. Why? Because those are our solutions. Those are our x-intercepts. When y equals 0, our point is on that x-axis, which is what we were looking for, right, for our solutions. And so now we can plot all of these points right here to make a graph, or we could just plot, okay, we've got our intercepts. We've got our point here at negative 1, 0. Let's do one more. Negative 2, we've got 7. That's all the way up here. At 0, we have a point way down here at negative 5. At 1, we have a point way down here at, negative 8. This point right here is kind of a key point. That is our vertex. That is the point on which everything turned, right? I'm going to erase a little bit of this because my graph isn't big enough to show you everything. So I'm going to just get this little scratch work out of the way. At 2, we have a point here at negative 9, right? At 3, we're back up at negative 8. Notice our y's are starting to match, right? At 4, we have a point at negative 5. At 5, we have a point way back up here at 0 again. And then at 6, we're back up again at 7. And these get connected. Notice that they don't make a V. They make like a smooth curve. That's what they call it, a smooth curve. All right. I don't care about getting all the way up to there. I'm really bad at drawing on this thing. I'm much better at drawing on the board. And you can see that if this was drawn pretty, right? If this was drawn pretty, we would just notice that here at this turning point, at this vertex that we have, right, that runs up along, right, at 2, 9, 2, negative 9, right? But what's most important is the 2. right? This is our vertex that divides this. If it were a straight line, you'd see that. Everything that's happening on one side is happening exactly the same on the other. If we were to take this and I were to have drawn pretty lines and folded it on that line, those points would line up on top of each other, right? Because it's symmetric. And that's kind of that pattern that we're trying to find when we fill out these tables. Now, this is the worst way to solve quadratics, but it is the best way to explain them, right? Which is why you're only getting 2 homework problems on this, right? What your homework problems are going to do is they're going to show me the table, and they're going to show me the graph, and you're going to give me the solutions. If you want to do the scratch work on there, you can, but you don't have to, all right? What I'm going to want to see is I'm going to want to see this table of your points. I'm going to want to see your graph, and I'm going to want you to tell me what your solutions are. And these are your solutions, right? This is his mouth. He's going to smile. Right? And he's going to have a little nose and some ears and hair. He's an attractive young fella with very wide set eyes. Looks like a melting pitchfork. With the teeth I gave him, it almost looks like he's got braces too. I want to do one more graph. So this one clearly has 2 solutions, right? We can see them, 2 points where it crosses the x-axis. Let's do another one, and let's do it in another color. Why? Because color is good. We should all have color in our lives. Let's try x squared minus 8x plus 16. Now, we're doing f of x. F of x equals, just so we know it's a function. I look at this equation and I see all sorts of things because I remember Algebra 1 pretty well. And I can tell you that this is a perfect square trinomial, which means that I know exactly what this is going to look like. I know exactly what the solution is going to be. Notice I said the solution, right? Just by looking at it, I know we're only going to have one. But we still need to try and solve it the same way. We still need to bring in a graph. Ooh, did you hear that little crack on my neck? Did that translate over the internet? Because it felt good. Felt like I've been waiting to do that all day long. Well, all morning long, I should say. It's not that dramatic. It's still early. Right. So because I know what's going to happen here, gives me a really good idea of where to start my graph. So I'm going to go X. I'm going to go Y. I'm going to just start with 1. Do 1, 2, 3, 4. I'm going to have a ways to go. 5. But we'll go until we get some repeat, right? So if I put 1 in here, I get 1 squared minus 8 times 1 plus 16, right? 1 squared is just 1 minus 8 plus 16. Well, that's minus 7 plus 16. That's just 9, right? If I put 2 in, I wind up with 2 squared minus 8 times 2 plus 16. Well, that's 4 minus 16 plus 16. Ooh, that's convenient because those cancel and I'm left with just 4. 3. 3 squared minus 8 times 3 plus 16. Well, this is 9 minus 24 plus 16. What is that? 9 plus 16 is 25. 25 minus 24, that just gives me 1. Look, I need more room. If I do 4 squared, right? If I plug in 4 for x, I've got 4 squared minus 8 times 4 plus 16. Well, 4 squared is 16. Negative 8 times 4 makes negative 32. I wanted to write the 2 before the 3, but it's negative 32. Plus 16. Fancy that. 16 plus 16 equals 32. So I have 32 minus 32, which equals 0. So we found our intercept, but we have to keep going till it starts coming back up. So let's go 5 squared minus 4 times 5 plus 16. What do we get? Well, that's 25 minus 20 plus 16. 25 minus 20 is 5. Did I do something wrong there? I feel like I did something wrong there. Like I should be getting a different number. I should be getting 1. Why am I getting... Four times 5 is 20.
You put a 4 instead of 8.
Oh, okay. That makes a lot of sense. Like, what did I do? Okay, so that's minus 40. Okay, we're doing much better now. That makes a huge difference. Like, I know it's got to be right. So we've got minus 40 plus 16. This is going to bring me back to 1, right? So we have started repeating. So now if I put in 6, I know my next point will be 4. If I put in 7, I know my next point will be 9. So we found that repetition. But if you notice on this one, where we start to churn, that vertex, that turning point, is at our solution, right? Which means that we are only going to have 1 point on here. Our vertex is going to be that point, right? That 4, 0. So if I put in my other ones, right, I've got 3, 1, I've got 2, 4, I've got 5, 1, I've got 6, 4. That is all I really need, right? I know where my did you see me just completely miss that point right there? Right? And these are going to go on forever and ever with that smooth V. But we have our solution, right? Our solution is our vertex, right? So when you went to write it, you could write it as a point. You could say solution is 4, 0 or x equals 0, right? Or you could just put it on your table and circle it right there. I'll know what you're talking about. You only have to do 2 of these, right? You guys know how to create these points. Sometimes, you might have to search for a while to find those. I'm going to give you a little hint. I didn't give this to my other class. I wish I had. There is a secret to finding a vertex. Nah, if I give you that hint, it requires me to teach you a whole bunch of stuff first. You'll get that hint later on how to find the vertex. There's a thing that we call, you go minus 2a over b, and it'll give you what your vertex is. But you have to know what a and b are, and that would require a much longer explanation. And so pretty soon, like as we move into this unit, you'll be like, oh, why couldn't you have told me that all along when we were doing all these points? But you might have to suffer a little bit. Here's the thing, though. I know that the 2 problems that I assigned you should be okay with all of that. I will give you a little hint on the second problem, the one that is negative. Start with putting in negative numbers and go to smaller negative numbers. I would suggest using all negative numbers in that because I know where that one kind of sits, and it sits kind of way over here. Right? Because that one's going to be over here somewhere. Like, I don't know where, but it's going to be over here somewhere. So start with negative numbers for your tables. Like, I don't know where exactly it falls, but I know it falls in the negative. Like, oh, I'm looking at the one I just did. I'm like, where did that problem go? I will tell you that I think one of your homeworks has two solutions. One of them has one solution. So there's an example of both of those in your homework. And there's only two problems. So one of them has to have the two. And you know, if you did the one that has the two and you do the other one, it's got to have just one. If you do the one that has the one and you do the other one, you know it's got to have two. That's all there is. If you want, though, let me stop the video really quick. Yay, I get to stop seeing me.